We have been getting used to the fact that science can solve everything. Miracle drugs, satellite communications, hyper-developed computing machines, interplanetary travel. But, can science really solve everything? To find out, we need to know what the foundation of science is. In the beginning, philosophers had the final word about anything. If they said something, it was taken as an absolute truth. If a philosopher thought of the atom as an indivisible particle, that was held as true above all other reasoning. For centuries, scholars thought that heavy objects fall faster than lighter ones. It was said that an esoteric element, called phlogiston, was the cause of combustion. How did things change? The scientific method. The heart of today's science is a system called the scientific method. The first requirement is observation. A man of science observes a natural phenomenon. The second requirement is the formulation of a hypothesis, a potential explanation. The observer tries to guess the cause, according to his previous experiences, or simply by wild guessing. The third requirement is experimentation, a series of experimental procedures through which the hypothesis is confirmed or rejected. This can lead to the modification of the hypothesis, or to the formulation of a new hypothesis which is closer to the results of the experiments. The fourth requirement is data register, in which a hypothesis is subject to measurements in standard measures, such as weight, volume, dimensions, etc. The results are recorded to constitute a data source to be used in any additional experiments, as well as to support the final hypothesis with solid information. The fifth step is to ensure that the results attached to a hypothesis are repeatable, which can further be tested and ensure the credibility of the current hypothesis. The sixth step is the publication of data and results, thus submitting them to the scientific community, so it can be exposed to all conditions in various geographical regions, environments, latitudes, etc. If the scientific community takes the hypothesis as valid, then it can be considered a theory. This does not mean that it is an undeniable fact, but an explanation supported by a large number of men of science. It may still arise that a flaw is found in certain applications or manifestations. If enough evidence piles up about the relative infallibility of a certain theory, it can reach the category of a law. This is usually achieved by developing it through mathematics. For example, the law of gravity, mathematically proven. Conclusion: the scientific method is the most impartial methodology, which has given greater impetus to science, since it presents the ease of correcting errors and assumptions without true and undeniable support. Limitations: anything which cannot be observed, repeated and recorded cannot be analyzed by the scientific method. New discoveries can alter even an accepted law, so science is not ultimately infallible. Unfortunately, all human beings have needs, flaws, and ambitions. If persisting in an error brings us financial gain, say, the publication of books, the sale of objects, or another form of profit, this will always be an obstacle to true science, which is so useful in the material realm. Thanks for watching and please subscribe to my channel. Shava Ta'in.